that with equal
I'm
reaction?
just asking a simple question. I'm trying to understand what you're saying happens. What are you saying happens? So we agree that you pump up a whole bunch of water. I mean, you pump a whole bunch of air into this rocket, and when you remove the valve that's holding it all in there, the rocket shoots off into the sky, right? We agree to that.
Yeah.
What do you think's causing that to happen?
The pressure in the rocket.
Gravity.
What do you mean?
What pressure in the rocket is causing that to happen?
The air pushing up against the water, and the water is expelling out of the.
Okay,
chamber.
and so what is it about the water expelling out the back that causes that rocket to go up?
It needs a surface area. No
I'm
surface.
asking Bon Jovi right now. What about that water leaving the back of the rocket causes the rocket
I'm the
to move in the
scientist, the
direction?
rocket scientist. Well, go ahead, Joby.
Well, it makes the rocket go forward because the air
Why?
is being. Because the air is pushing up against the water. What do you mean why? You gotta be more specific.
Okay, so the water has left the rocket, right?
Yes.
And then you have air pushing against that water. Okay? How does that affect the rocket? Because now you said is you have air pushing against the water. How does that affect the rocket?
Why is Homeboy freaking out?
Yeah, how does it affect the rocket?
He gave you the answer earlier.
Homeboy's freaking out. I don't know why.
I don't think he's freaking out.
Like, how does it?
Bon,
I mean, it's
Bon
very
Jovi
simple.
already.
Get a vacuum.
Bon Jovi, how does it affect the rocket? Come on, man.
You're stressing me out, man. To be honest.
I know. Homeboy's like. Goodness,
Yeah, like,
I'm walking through this slowly with you, which very few people here actually do. I'll walk through this one step at a time and try to get you to understand each and every step.
Okay, let's see.
Look, dog.
And then maybe you go, oh, yeah, huh.
Well, it's just because
now I understand.
It's because the motion of the
Look, this cat is
the air pushing up against the
cat.
water. It's going in the opposite direction because it's one of the laws of motion. That's how I understand it.
What's wrong with this cat, Joby? I mean, all he has
which
to do...
which law of motion is that?
I'm just gonna say the third law.
Well, okay, we don't have to identify which law, but what's the principle? What's the idea that's making it move?
Every reaction has a equal. I mean, every action has an equal reaction.
Exactly. And so it's the water itself that has a mass to it, right? And that mass is being pushed in one direction, which requires a force to put in that direction, right? And that force is required whether or not there's atmosphere outside that rocket, right?
Yeah, it doesn't matter for the atmosphere outside.
Yeah. And so whatever force required to push that water out in one direction is going to be countered by a force in the other direction, right?
Yeah.
And so we don't require atmosphere in order for that water rocket to work, do we?
Yeah, I mean, it wasn't my claim, so.
Okay. So you're like percent and not like Chemo. All right, that's cool. So Chemo, you're on an island here.
Well, again,
everybody else understands this, but you, Chemo.
Well, for me, without the atmosphere, without the thing to push off, you'll never be able to demonstrate this. So you can come with the.
It's not pushing off.
Okay, so Chemo, how do you think it works then? The water leaves the back of the little rocket and does what?
So it's got.
What eventually makes the rocket move?
No. So in this situation,
he's not honest enough to answer.
You've got the surface, you've got the ground for it to push off.
No, there's no ground. You're holding it up in the air. You know, you hold these things up about at arm level or whatever, and you pull back this little lever, and the rocket goes.
You've got your hand. You've got your surf. You've got your hand. It's going
to. But that water never hits. That water never hits my hand.
Yeah, but it's got the surface for it to do it in a vacuum where there's no
surface. What surface, no Chemo? You said it has a surface. What surface?
You said your hand. You've got your hand there, yeah?
No, the water never hits my hand.
Well, then do it in a vacuum.
And even if it did, Chemo, even if it did, how would that affect the rocket?
Because you wouldn't get any reaction in a vacuum.
Why not?
Because there's nothing to push off. How many times should we tell you this?
Do you have any observations or measurements that this occurs?
Look, this is nice poetry. We can write songs about this when there's war, but now we need science, experiments to back up the claim that rockets can move around in a vacuum. You're just talking about it. To concede for now, tonight we should concede. Tomorrow we can... what?
So somehow you're saying the atmosphere helps propel the rocket?
No. I'm just saying without the surface area, you won't be able to move anywhere. It will just spin around.
But why not?
Because in space, it would just spin around in a circle.
How you said it couldn't move?
It would
But
move.
why would it spin in a circle?
Why would it spin in a circle?
Yeah, what if you focus that energy, that explosion of mass into one direction? Control it.
Well, it depends if it's still got its momentum. Like if you took a jet straight up, it's got momentum, hasn't it? But if you just dropped an object, it wouldn't move. No, you wouldn't be able to get any thrust.
Wait, hold on a second. Let me ask you a question. Did you just make that up just now?
No. When you look at the because in the 1970s there was and the 1950s, 1950s and 70s, they were sending up high altitude aircraft to the upper atmosphere, and they couldn't maneuver. They would fall back down. That was the beginning stage. After World War II, they were testing how high they can go. So I think it was
But
the
you
F-15.
said it would. You said it would spin around. What?
That's
would make
if
it
it's got
spin
momentum.
around?
But again, if you just dropped something in the middle of space, it just wouldn't move.
But why not?
You've got nothing to push off.
Yeah, sure it does. The wall of the chamber, like
Wall
so.
of the chamber.
If in our water rocket example, right? There's a chamber of water and air pressure. So
No, but if you've got this low pressure,
it has only one escape. Like it has only one escape route. Like
Yeah,
so,
but-
if there's pressure in there, it's going to try and equalize, right?
No,
so
no,
when you
no,
open up the valve, it
No, the gas
all the
will
air
try and
escapes
fill,
out.
Yeah, it will fill the space, so it will have nothing to push off. We'll be able to move.
Why don't you think that the pressure that's inside the chamber once you release the valve isn't pushing off of the walls to escape the open valve, the hole in the open valve there? Why don't you think that the pressure is pushing off all those walls, right? That's the thing, right? You're saying that it can't have air pressure without
What
a container,
are you talking
right?
about, dude? You're
the
saying...
reason why there's air pressure in the container,
You're
right,
rambling
is
now
because
because you know that you're talking nonsense. So you're saying that
Yeah.
you've got a box.
I'm talking nonsense.
Yeah, you're just rambling. So you're saying you've got a cylinder or a box with pressure inside, and that causes the rocket to move.
Well, no. If you have pressure in the rocket,
Yeah.
and it's equalized in
What?
the
See,
container.
hold on, slow down. So
In
you're
the
building up
container.
pressure. Hold on, you're building up pressure in the rocket. Yeah. So what? Yeah. What? What's next?
Well, let's say we already have pressure.
Let's say you
we're
got
done
pressure
building
in the
pressure.
rocket. Yeah.
It's just sitting there. It's just
High
sitting
pressure
there.
inside the rocket, low pressure outside. Yeah. What's next?
Right, and then you open up a valve, right?
And then
which
what
is
will
just a
happen if
tiny
there's-
hole
Yeah. What will
Out
happen
the
as soon
end
as you
of-
open the hole?
end of the rocket. What happens now?
What do you think will happen? It will fill the space immediately.
All the air escapes, right?
Mhm.
Well, most of the air escapes, the pressure of it, right?
All the air escapes. Yeah, that's right.
to try and meet
All the gases
equalization.
would escape. Yeah, and fill the space immediately.
Right. So
yeah.
when those gases escape, what
Yeah.
are they pushing off of to escape?
Not pushing off
What are they
anything.
just?
They're just going to fill the available
They're
space.
not. Why not? So were they pushing off of anything before the valve was closed? How do you know you have pressure?
You just said there's a buildup of pressure inside the chamber.
Right,
Make a
but
hole.
like, how do you know there's a buildup of pressure? Right,
Because you
by
just said so.
by the pressure on the walls, right?
You just said that. You just said there's pressure on the inside, then you open a hole, then it comes out the
Yes.
hole. Yeah, now what?
But there's pressure because it's pushing up
What
against
are
the
you
walls,
talking
right? All the air is pushing up against the walls, right?
So you've got a chamber, a box, you fill it up with pressure, you pressurize it. So now what? You need
Yeah.
to make a hole. Okay, now what?
Oh, well, you already know what happens. You just
What
told me.
happens?
The air escapes.
The gas escapes,
The
yeah.
pressure escapes. Yes.
And then what? How does the rocket move?
But how did it escape? Why did it just stay in there?
The gas will fill the available space if there was low pressure outside.
Right. So the gas moved from one area to another. How did it do that?
How did it fill the available space?
Yes. How did it do that?
Are you okay, dude?
No, I wanted to know if you know how it does that.
High pressure to low pressure. You don't understand this?
Well, sure I do. I understand it completely.
So what are you asking
I'm trying
me
to
then?
understand it.
You got high pressure in the container.
Trying to understand your understanding.
Well, you got high pressure in the container. You got low pressure outside. What do you expect to happen?
Well, I expect the high pressure to escape into the low pressure and
What, and
to
just sit
equalize.
behind the rocket, nice and comfortable, like a little cloud.
No, it's under pressure.
No, what comes out of the rocket? What happens to that gas? Will it just sit behind the rocket?
No,
Well,
it's
no,
being,
it'll
it's being
continue to
expelled.
move until acted upon by another force, right?
I'm asking you, what do you think will happen? Do you think it will just sit behind the rocket like a cloud, or shoot off into the available space?
Shoot.
No, he's asking you, Chemo. Don't try to put it back upon him.
Well,
Go ahead
I
and
can answer the
Chemo.
question,
But how
right?
stupid, how silly is this? What is wrong with you,
obviously the
born
air
earthers? How silly is this? You're
shoots
asking
off
me
in all
high
directions
pressure,
outside the
low
nozzle
pressure. You say
to
if
try and fill the available space.
Let's think about it. If we've got a chamber on Earth, a vacuum chamber, and we open the lid or make a hole, what do you think will happen?
Air fills in an equalized pressure from both sides.
So, if you've got high pressure in space in the chamber, you make a hole, what do you think will happen?
The air escapes and attempts to equalize.
Equalize how? Where's it going to equalize?
It's going to fill the available space.
So how much space is there to fill?
Well, we're talking about space, so space.
So then how would it be able to push off anything then? How would it move forward?
Well, how did it get outside if it's not pushing off of something?
Well, you tell me that. How did it get outside?
No, Chemo. You tell that. This is the question to you. Do not
No, this
try
is
and
not
twist
my
it around to
claim
make
that they
him answer.
work. This is not my
Yes.
claim. You've just
Yes,
explained.
it is your claim that it pushes off of something outside, a medium. So go ahead and define that.
No, he's
See,
saying that it creates a medium in space and pushes off that.
It creates a disequilibrium because now there's some place
What do you
for
mean
the
it
air
creates
to
a
get.
disequilibrium? Well, what are you talking about?
Well, okay, so since the air is escaping,
Gas.
it's
The
moved.
gas is
It's got
escaping the
it
rocket.
has
Yeah.
movement. It has movement, right?
Yeah.
So what happens when you have a force like that?
Gas will fill the available space. Yeah.
It really is. It really is like,
Can I?
it's
Sorry.
like talking to a 1-year-old that hasn't
No,
learned
it's
how to
just he
speak it.
knows the answer. He doesn't want to say it because it starts falling apart about his further claims that there has to be an
There's
external
pressure in the
medium
tank.
to push off of.
That- They'll explain to you what the pressure is, right? And like they'll say you can't have gas pressure without a container. Okay, so if you have a container and you have gas pressure, what does that mean? It means that the air is pushing against the walls, right? Equally all the way around. Well, what happens when you put a hole in it? Okay, the air rushes out to fill the available space, which causes a force. That force, opposite direction from way it's going out, is pushing the rocket the other way. I mean, it's fucking simple, man.
Well, if it was
Don't make
that
it difficult.
simple, you would have demonstrated it. So let's try like this. Let's build a rocket or mini rocket on Earth here, model. So we're gonna have an exhaust where things come out of the back, like a balloon or something, and then we're gonna take a vacuum and put it next to where the gases are coming out of the exhaust of the rocket. So why doesn't the rocket move forward with the vacuum near the exhaust?
See, that's a false question because you're automatically assuming that the rocket doesn't move forward when we have multiple observations of that actually occurring under those exact conditions that you just stipulated.
So let me see that then.
There's a lot
You've
of
been
videos.
shown this multiple times that there are rockets in actual vacuum chambers.
No,
and one of the
I'm not
common
talking
things
about
is then
that.
to change the goalpost of saying, oh, it's not a big enough vacuum chamber.
No, I'm not talking about that. I'm saying if we take a model.
That is exactly the conditions that you just stipulated of putting a rocket in a vacuum chamber and then to show what it does. But then you just tried to ask a question, falsely assuming the rocket doesn't move forward.
No, that's not what I said. So what I was
That
saying.
is exactly what you said, Emo.
No, that's not what
Try
I said.
again.
That's not what I said. No, you're wrong. Try to listen. So if we make a model...
Oh, I did just listen, and so did everybody else. So go ahead and why don't you try and address the previous question that he asked about when the actual chamber becomes open, how does it actually move?
No, you didn't
What
listen.
happens
You
to the
didn't pay
gas?
attention. You need to listen, open your ears, and try to pay attention to what's being said. Remember, we're the science communicators, not you. You have no evidence. You have no proof. You need to understand your position in this life. Okay? You're someone who parrots the information
Just keep on
from
making
the system.
false claims, Chemo. It does
Well,
not
again,
actually
just try to
substantiate your
remember who you
position.
are. You're a globe earther who believes the Earth is spinning, flying through space with
Oh,
zero
Chemo.
evidence. Yeah?
Chemo, no
No,
one says
it's
that.
not
Chemo.
belief, first of all.
That is a belief. It's your religious belief.
Second of
You
all,
have no
you
evidence
still
for
aren't
it.
providing any evidence.
You have no evidence
Chemo.
for it. No
Chemo.
proof for
Chemo,
it.
you're spiraling.
No one's
Chemo,
spiraling.
you're
I'm saying
spiraling.
that he should remember that he is a guy
Yes, you
who
are.
thinks the
Chemo.
Earth is moving, curving,
We know,
and
we
flying
know
through
that it's
space in a
moving and
vacuum.
curving.
So for him to say,
It's
"Oh,
not flying
give
because
me
it's
this
not
experiment,"
aerodynamic.
who is this guy who has never done an experiment in his life, never conducted any science in his life, and
Just
wouldn't
like-
understand
just like
the
you then.
method without a
Talking
course
about
of a
Just
year
like,
or two?
just like you then, Chemo. That's projection.
It sounds like he's describing himself.
Exactly. Yeah. Describing you, Chemo. But Chemo, what is pressure? Is pressure force per area or force exerted to the walls of the container?
So as I was explaining, if we take a model rocket, we can build one ourselves with like a balloon, and we can create an exhaust. We can create a low pressure behind the high pressure, and we can see that the rocket, the model rocket, does not move. So we can create a vacuum at home. You don't have to have a big, large vacuum. All you're trying to create is a low pressure versus a high pressure. And what you'll find is the rocket, the model rocket.
I can do that.
Yeah, that
hold on a second.
shows.
I can do that. I can blow air into a balloon and then just let it go and it'll fly because there's higher pressure inside the balloon
Mm-hmm.
and the gases are exerted out to the lower vacuum, which is not a lower pressure, which is outside of the balloon.
Yeah, that's correct. But
Yeah.
when we try to
So
experiment,
there's your demonstration.
when we try to experiment with a vacuum, what we find is that when you have the low pressure,
Now we can make a vacuum at home. You said we can easily do this at home.
absolutely.
But that's not what we find. That's your delusion talking again.
Well, we absolutely
about, like,
do
our-
find that. What we find with this.
But we
video
don't. Chemo, but we don't. Let's stick with reality. Stay in reality with it.
Well, again, you have no experiment, so again, you're not in the position to communicate.
Chemo, you have no experiments either.
What we have here is an experiment.
What is
with...
pressure, Chemo? Chemo, what is pressure?
Well, first of all, let's stick to the first point: is why.
I'm on the first point.
Let's mute Chemo.
Well, let's stick to the first point. Why the rocket, the
I am
homemade
on the first
rocket,
point.
doesn't move when we have low pressure behind it.
You have no experiments to back that up as a valid claim.
Oh, I've just posted
Show me
it for you.
evidence.
I just posted the experiment for you showing that when you have low pressure next to high pressure, the rockets will not move. Now, this is an experiment anyone can do. You can see it there in the chat there. It's been repeated, replicated. We have the facts, figures, and numbers, and you guys have poetry. That's what you need to understand.
Figures and numbers. You don't have any facts. You have no figures and no fucking numbers.
Well, I presented it here for you in the chat. Again, when we talk about rockets working in space, you'd have to show that low pressure next to high pressure is viable.
No, we don't, because
every rocket ever.
That would be a straw man.
That's the definition of rocket, right? Like low pressure next to high pressure. That's the definition of any rocket. Every rocket.
It's not exactly. Not if you listen to him closely. He's saying if you have a low pressure and a high pressure, simply having those together would move it, right? But that's not what's happening, right? It's the it's the force of the movement of the matter from high pressure to low pressure. So, yes, it doesn't necessarily matter. Well, I mean, by matter of fact, it's high pressure to low pressure because that's just physics, right? But that's not the thing that's actually making it happen. That's just a matter of fact. The thing that's making it happen is the fact that the matter that's in high pressure, once released right through the hole, moves. And once you have movement, then what happens?
You finish your
Yes.
finish your poem, Damon. Finish the poem.
Yeah,
The
for real.
opposite reaction, right?
Can
The
you just-
opposite reaction happens. Which case, the gas comes out one side, the rocket goes the other way. The rocket goes up, the gas goes down.
That's a nice
Jeremy,
song,
can we
but
hear
like
the
I
say
say,
chemo?
without the experiments, it's nothing but poetry.
Oh, Timo, I checked the video, and it's not closely analogous to rockets working in a vacuum.
Well, what's the difference?
What's
First
the
of all,
difference?
where's the
In the-
vacuum?
In the video, there's a balloon that's flowing air
Mhm.
from the back
Mhm.
onto a surface. What's there,
Mhm.
which is the paper,
Mhm.
and you don't have that surface in a vacuum.
Why can't you just show them the demonstrations of all these little model rockets NASA must be testing in vacuums?
Not possible, Jeremy. Like I said, they're not the
I don't understand why.
communications. We are the
So
science
Jeremy,
That's
educators.
Kimo, that's
How
Kimo.
rockets work. We're good.
Yeah,
You're
Kimo,
done testing
that's
them?
why I
Yes,
that's
we
why
are.
I asked what that's why I asked Kimo what pressure is. Because if pressure is force exerted on the walls of the container, and you take one wall off, then you have force on the other direction. So I mean,
Entropy is a force.
it's quite simple.
You're saying.
Entropy is not a force.
I feel like you're saying it is.
Jesus.
You're
No,
like
I
you're
didn't
saying-
say. I said pressure is a force.
Jeremy, why
I said pressure is a force.
You were saying
You'd be wrong,
entropy was a
No,
force.
no,
No, we
Jeremy,
could be
Jeremy. Where did I say entropy is a force when I was talking about pressure?
Sounded like that's what you were getting at.
Jeremy, why can't
No,
chemo do
I
the...
said pressure is a force.
Oh,
Well,
Jeremy,
maybe we should listen closer then.
hey, Jeremy, why can't
Jeremy.
chemo do the experiment himself, man? Why do you have others do it for him?
I'm
Not
saying
our
we're done.
claim,
Okay,
it's your
Mackie
claim,
said,
Pyro.
Mackie said
Because Kimo
Hold on,
can't
Ma-
back
hold
up
It's
on.
his
not our
claim with
claim,
tests.
that's
Matt-
why.
Mackie said it's not our claim, and Mackie said they're done testing rockets. We know how they work, so we're just
Well,
going to stick with this rocket forever and
Well,
never
chemo
test.
claim...
We know.
well,
No, we
chemo-
know how rockets work, Jeremy. Yes.
So we're done testing rockets.
No,
Well-
we are not done testing.
Still testing rockets.
SpaceX is testing rockets right now. It's called
They just
Yes,
shoot them up
and-
and hope. They
SN10 sitting on the launch pad right now, ready to go.
Test-
But not to verify the principle of rocketry. They know how rockets work. They want to see if they can get
I can.
more efficiently, get more horsepower out of them, get more thrust.
They're testing
no,
new
they know how
rocket
rockets work.
designs. Yes, they're testing new rocket
Yes.
designs. Yes, and that's true.
Not here.
Not
on
to
Earth,
verify.
though.
Will this
We just
rocket
have
if
work
to-
at
I-
all?
Not here on
This
Earth.
one-
If I want to
Fly
tune
off
my
this-
car,
Not here on Earth, though. From now on, we'll just have to trust that they're doing it in the sky where they say they are and everything.
You don't have to trust anything, Jeremy.
Why
You
you
can
gotta
remain
trust?
ignorant also.
Look at
You
it.
can
Just
remain
fucking
ignorant for as
watch
long
the
as you
damn
want, man.
videos. There's literally a 24/7 fucking goddamn camera right here in
Yep.
Boca Chica. Several different people, fucking many different angles, freaking people flying drones over it, people like hundreds of people literally recording it almost 24/7. And some of them are recording it live 24/7. You can go there, meet the people, look at the cameras, go back home and watch the fucking feed. Are you telling me they're lying somehow? Like, what are you,
Yes.
retarded?
No, he is actually.
Well,
Exactly
you
what
could
he's
be
saying.
lying.
Like,
You
that's
could be
the
lying.
If you would like
They're not
to.
lying. You
They're
could be lying
lying to
because you're not
themselves.
proving it.
If you would like,
further
there's
the
a video
fucked up
that I just
way of
posted
thinking.
of a guy who built
Why would
a
they
small
lie?
vacuum tube right behind
Why
his
would
garage
they not?
and did a rocket test in the vacuum.
I'm saying, Jeremy, you can go do it right now. You can
Prove your
go
claim.
do it.
I can
Have
go
a
prove
live
your
feed.
claim that rockets work in a vacuum.
Of course they do. Why wouldn't they?
So, but it's on me to go prove your claim that they work in a vacuum.
Well, chemo's
No,
claim...
you don't have to prove it.
You can
It's already
remain
proven.
ignorant.
You're the dumb
You
motherfucker
can
that thinks
remain-
rockets
you
can't
can remain
fly in
ignorant.
fucking space. You
You're
fucking
an
remain ignorant because
American.
you're trying
You're
to-
free. You're free to remain ignorant.
You're
Jeremy.
literally
Please
a
don't call
dumb
me names
motherfucker.
because you're
You know
trying
that,
to
right? No, you're a dumb
you know
motherfucker.
that
Please
the
don't call me
Newtons.
names
You're so
because you're trying. All
You're
right,
so
don't-
stupid.
Jeremy.
don't need
People
to
have been
insult because you're
describing
doing
this
a
shit
burden
to
of
you,
proof
just like
reversal
fucking.
fallacy.
No, you're a liar or you're stupid. One of
You're
the
just
two.
doing a burden of proof reversal.
You're a liar
fallacy
or
and then
you're
calling
stupid.
me
That's
names.
One of the
exactly
two.
what
Which
you're
one is
doing,
it?
Jeremy. You made a
committing two
claim
fallacies
that they
right
don't
now.
work, and you don't have
committing two
evidence to back
fallacies.
that up.
In defense of rockets.
You
Jeremy,
don't even know
Jeremy.
what fallacy is, apparently.
Jeremy,
Well,
does
you're trying to reverse the burden of proof
Je-
onto us,
Jeremy.
for one. Hold on a second,
Jeremy.
old man.
Burden
Hold
of
on a
proof
second,
has
please.
been met. You've
Can I address the fallacies he just committed or no?
burden of proof
No,
has been
because
gonna
he
skip
hasn't
right over
committed
that.
a
I don't think
fallacy.
you can.
You have committed the
We're gonna-
fallacy
We're
by
gonna
not
skip right
offering
over
proof
part.
for your
All right.
claim that the rockets don't work.
Jeremy.
in
I was
light
rude.
of
I didn't
the
put
evidence
fallacy.
that they do.
You're making a claim rockets work in space, right?
Well, Kimo
No,
made the claim
I
first.
don't.
You're
No,
making a
that's not
claim
right.
they
rockets
don't.
work in space.
That's not your claim?
The claim is already been made. Yes, the rockets
Okay, there we go.
work.
Your burden of proof is on you.
Well,
That's
no,
the
wait,
burden
hold
of
on.
proof on
Okay.
you,
Hold on.
Jeremy,
Kimo
to
made the
prove they
claim.
don't work
And
when there's
Kimo-
evidence that they do.
Okay, I made a claim.
Me.
Rockets work. Burden's been met. Okay, all the evidence
In
is there
space.
for you to see, and you've been reading and looking and videoing and fucking maybe even doing an experiment yourself. I doubt it, but maybe. For how many goddamn years now I've been watching you in this server where people have described this to you, shown you videos, shown you experiments for fucking years now. So when are
Bro,
you
you don't
going to
even know.
accept that you
don't
have
even-
the burden of proof because we have met the burden of proof?
You
And you are
obviously
making
don't
a
even know.
claim that rockets don't work in space. So prove
obviously
your
don't.
fucking claim. Prove your claim. Prove it.
Are you
Prove
done?
your claim.
Are you ever going to be done with this monologue?
No, I'll keep
So-
on forever until you stop being so fucking stupid.
So,
Well, you got a long
despite the
monologue
two
ahead of you then,
fallacies
man.
that you've committed,
Incorrect,
despite-
Jeremy.
despite the two
Incorrect,
fallacies that
Jeremy.
you've already
You
committed.
are the one committing the fallacy. He made the claim, he provided evidence for it, and then you made a claim that it's not correct and have not provided any evidence.
They want to see real life on Earth
But you don't.
evidence.
Me.
You,
Jeremy.
but you're lying to yourself if you
That
that's
guy
what you-
doesn't even know
They're
me,
both
obviously, 'cause
do.
I don't even like this argument. So
They're-
whoever that
I mean-
Damon guy is, you don't even know who I am.
But
or
how
who
come
you're talking
Jeremy?
to,
Of
obviously.
course
I know
I
you-
do. I've been
we know who you are, Jeremy.
fucking listening to you for years in this server.
We know you.
The fact
and we
that
know
you
you.
don't know who I am
was
is
ignorant.
more evidence of your ignorance. Like, what are you on drugs or something? You forget?
Everyone knows I don't even like this. Rockets don't work in
Jeremy,
space.
can I ask you a
argument, so
question?
You clearly don't know who
Then
you're
why
talking
are you
to.
defending it, Jeremy?
Because
Why-
you're committing a
why are you
fallacy when
defending
you
it?
try to revert.
Incorrect, he's not committing a fallacy.
Fallacy. Show where I was a fallacy, and
Not,
I'll correct myself.
that's not
show
cool
me where I
when
made
you
a
try to
fallacy.
reverse. It's not cool when
Me.
you try to do
Can
a
I
burden
ask you a
of proof reversal
question?
fallacy on chemo. So
Then
that-
don't
and that-
do it,
that's where I
Jeremy.
gotta-
Don't
That's
do
where
it,
I gotta
Jeremy.
jump in.
That's exactly what you're doing. Is a
I'm
reversal of
jumping
burden
in
of
because
proof.
you guys are
What's the
committing
fallacy?
fallacies
What's the
that
fallacy?
are ridiculous.
Oh, wait, hold on. Jeremy,
There's a
Kimo
fallacy.
made the claim that rockets doesn't work in space without evidence. Shouldn't he be the one that proves it and do the experiment since
No,
he's
you
the one that
guys
made the
have been-
claim first?
Nope, you guys have been claiming since the 60s that rockets work in space. It's your claim, not ours.
Your claim is that they don't work in space.
Yeah, we
Do you
don't think it
understand that or
exists.
not?
We don't
Like,
think
all
A
that
the
lot of
exists.
evidence of rockets working in a vacuum.
Rockets working in a vacuum. They're
Despite-
saying it doesn't exist.
Despite literally
Non-existent.
terabytes
You can't make someone prove non-existence.
worth of
It's
evidence,
ridiculous.
despite actual evidence that you can go see yourself if you wanted to, if you cared, if you gave a shit instead of just being a troll.
They have
You can
evidence of
actually go see it
rockets working
yourself.
in vacuums. Where?
See, that's a false
Jeremy,
claim.
can I ask
just
a question?
to attempt to prove non-existence because there actually
Jeremy.
is existence and proof of it working. So you have to provide a burden of proof that it doesn't work, and you haven't even met that.
I'm a
I have a question for
Glover,
you.
and I think I'm siding with Jeremy here. To claim that rockets work in space is a positive claim. To claim that the stuff. So I would be, even though I disagree with his conclusion, I would agree with there. But what I would say is that
Thank
all of the
God.
stuff in space has been faked. That's a positive claim. That's a claim that
Who
requires
just
evidence.
said that? Thank you very much, whoever just said that.
Did you miss the last part of what he said?
Jeremy, that's why I have a question for
At
you.
least somebody's reasonable in here and knows what's going on.
Did you miss the last part of what he said?
Thank you.
I am reasonable. The problem
You
is
missed the last part, didn't you, Jeremy?
Can I ask a question?
if there. Okay, do you believe that cars go down the road at 60 miles an hour?
Yep.
Why do you believe that? There's no evidence of that. Prove it.
Do you believe
little
that
silly,
do you believe there's a North American Loch Ness
I
monster?
want to see it. Prove it.
It's a
I
little
have,
silly.
liar.
I have 100% proof in the chat right this second that in the
Come on,
year
David.
2000, that in the year
Jesus.
2015,
Dave's
it
going
has
back
been
to zero
fully
for May.
documented that the Loch Ness, there are more than one Loch Ness monster. If everybody would please
Can't be
refer to
Loch
the
Ness
video,
monster if it's not in Loch Ness.
It's only.
Well, they got the
it's
Lake Champlain monster, I think, and
Yeah.
is there another one, Dave?
Don't even respond to him.
Rockets in space, man.
Please
They're-
don't respond. Please don't respond to
But
him.
Jeremy,
Please don't
Came
a
out the
million-
woodwork with
a million-
it,
begging you.
what was the point, Dave?
I had a question for Jeremy for a long time. But
Go ahead, sorry. I'm a little
sorry,
riled.
does every action have an equal and opposite reaction in your view?
Listen, I think rockets could work in space. I don't like this argument. I told you.
Okay, never mind then.
Still, the burden of proof is on you guys.
Yeah, but we don't.
That doesn't mean it's okay to do a
Jeremy,
Do you believe rockets
Jeremy,
land
oh.
backwards? Do you think they land
Come on.
backwards?
Let me
Come on,
just
David. So Jeremy, the Newton's third law works. So
I mean,
do
you
one more.
believe they go up? Do you believe they can land?
Just let me have
too?
one more statement.
Listen, theoretically, rockets could work in space. That doesn't mean it's okay to do a burden of proof reversal fallacy on chemo. That's all I'm saying.
Because there is
Okay.
no burden of proof reversal fallacy. The fact of the matter is, we have this claim that rockets work in space. We've provided multiple actual burdens of evidence to support it. Then he comes with this claim that they don't. So he does actually have to. And that's another error, is to automatically assume that negative claims don't require a burden of
Jeremy.
proof.
Jeremy.
Chemo, have you seen? Hold on, chemo. Have you seen evidence of these rockets working in a vacuum or no?
I'm just trying to explain to them, if we look at this image from Damon, got this gas entering into low pressure, so the gas would immediately fill the space, and the rocket wouldn't be able to operate.
Yes, Mood. Did it come out of the container?
What the gas is?
Did the gases come out of the container?
Yes.
There you go. You just fucking agreed with me. Now you know rockets work in space.
Oh.
Yes, you just agreed with me.
no.
Rockets work in space. The air moved outside of the container.
All right, let me ask a quick question, Chemo. If rockets work in space, how come airplanes don't work above 20 miles up? You know how an airplane can only fly so high?
Don't answer him. Just ignore him.
Let's talk about this.
Please. Everybody here, please don't
the,
answer him.
You've got
please.
you've got the Blackbird, right? And it can go up what?
Please.
100,000 feet, and that's it, right?
Hey, man, let it go, man.
I'm letting it go.
No,
Right?
I mean, let's talk.
Thank
Let's
you.
talk
David,
about it. And
David,
Thank you.
then
David,
after
you know
that point, and then after that point, your supposed rocket has to kick in, and then it has to fuel its way up or pressurize its way out the ass end of a rocket by thrusting gases out the ass end, right?
Could we
Because
put it on
there's
the airplane
no
and
longer-
open up the door?
Because there's no turbine that can pick up any air to push out the engines, right? Because that's when it stops at 20 miles up. Do we all agree?
No.
No, don't. We had it.
Yeah, of course. The turbine stops working because it can't force any air into it and out of it.
Right. So we've got just the window of how high the ceiling of this planet is only 20 miles. When you could take a big jet up there and it can't fly anymore, you could take a house fan and put it up there and it wouldn't blow any air if you turned it on. Like say you took a shop fan, turned it on, nothing would come out the other side. It would just spin on itself and nothing would blow. You got it?
Absolutely.
Don't feed David. Don't feed David.
Sounds like a positive claim,
What would happen if you had a container of pressurized gas and then you let it go?
Listen to me. So you're at this point,
How
and you're going up. And there's no more air. This is where your vacuum. This vacuum. It has a definite area because we have airplanes that can only go so high. So this ceiling is only 20 miles high.
Do you know why the airplanes only go so far?
What is your point? Get to the
ceiling to our planet's only 20 miles high above our heads.
That's a claim, dude.
No, that's a true fact. If an airplane won't fly and it's 50 below zero, you got to remember
that's because the air's too thin for the plane to fly
it's
up.
Windless, exactly. It's windless and weatherless, right?
There's
Windless
no-
and
Of all of the of all of the positive claims that require a huge burden of proof, the container's a real stonker, isn't it? It's where does it meet the earth? How high is it? How permeable is it? Does it flex at all? Does it bounce things? That's a huge improbable thing that just to go, well, because I haven't seen anything to the contrary. It's like, no, that's a huge claim. That's the one that needs to satisfy a burden of proof. The container is very weird.
Your vacuum has a line of where it starts at. You've got like a 20
No,
mile.
it doesn't. No, it doesn't.
Yeah, that's where your vacuum starts at.
No, it doesn't.
If an airplane can fly in our atmosphere and there's plenty of air below 100,000
the
feet,
container, David.
I know where vacuums start.
Tell it where.
All vacuums start in between.
And all of a sudden,
Dave,
airplanes won't fly anymore.
Dave, all vacuums start in between two mediums. When you go from one medium to the next, it acts like a vacuum, a differential of pressure, temperature, or otherwise. High to low, hot to cold, it acts like a vacuum. It acts like a magnet. It's all the same shit.
Create a low pressure and a high pressure. Yes, that's a vacuum.
So you agree
two mediums.
There's no differential. There's just less air.
It can be within the same medium.
Because we could discuss where airplanes can't fly anymore, right? We know that height, because we know what the Blackbird for the military, all jets, man-made jets can only fly up to 20 miles up. That's about it. Even the Black Hawks and all the ones that fly around the world at Mach 2 or 3 or whatever, they all can only fly. They have to fly below 20 miles high.
So they don't bump their head, you mean?
What?
So did you just say that having air and air is a vacuum together?
Well, the point being is above that point, anything above that point, you have to use a rocket.
Yeah, I said you need two different mediums or two reactions. You said you need one medium. One of you guys did.
I'm saying that you can create a vacuum within the same medium just by creating.
Oh, you can create one within the medium. Okay, yeah, well, sure. I mean, yeah, you can create a type of vacuum. Yeah, of course.
Yeah, I mean, there's two different uses of the vacuum there, so I'm not trying to equivocate. I mean, the vacuum, when we say the vacuum of space, that's different, right, than what creating a vacuum.
Right, of course.
The vacuum of space is at 20 miles up. Okay, the vacuum of space is 20 miles up. So are we all on the same page where that's where space starts?
We're all not listening to you.
No, I would say it's a gradient. Starts at high pressure down here and gets to lower and lower and lower and lower and lower and lower pressure.
If you have not one man-made object except something that can go above that point, has to be rocket propelled. Do we agree that? So it has to have a certain amount of gases thrusting out of the ass end of its rocket to be able to propel above 20 miles up. Do we agree that every rocket would have to be able to do that?
No. Technically, I think it's possible that you could have just a solid projectile with enough momentum would be able to reach space. Yes.
Yeah, that's what they say about sort of panspermia, the idea that there was once an ancient planet that got hit by an asteroid and it was covered in bacteria and it sort of spattered gunk all over the galaxy. That's what sort of one of the theories of the origins of life, that you could have it without a rocket, just a significant enough impact to a planetary body could shatter it and eject stuff out of
the gravitational forces of the original.
Yeah, sort of I'd be able to overcome them just through sheer brute force without anything coming, as David puts it, out the arse end of something.
But I think even we could just make a large enough cannon, a solid.
Yes, hang on. Wasn't there a thing with the nuclear test where they put a nuclear weapon down a manhole, and one of the theory, and they never found this sort of manhole cover. And one of the theories was, some people thought it might have got vaporized, but one of the theories was that it was shot off at escape velocity. I'll Google that. That might not be true. Hang on, manhole cover in space.
That sounds a bit of a stretch.
No, I actually did hear that too, and that was one of the theories.
I would melt it before it be shot into space.
I'll put it in the chat.
What temperature does a manhole cover? What can it hold till? It's just steel, right?
Probably a few thousand degrees.
Right.
It would also depend on whether
it would melt.
Yeah, it was depending also. Some of the theory was it spinning end over end like a flipping coin, in which case it would really struggle to Or was it spinning sort of like, you could imagine throwing a
Then they
disc
should have found it though, right? They would have stopped
that thing,
eventually.
That thing
Well, it
shot
could have
up
got vaporized
straight.
into small pieces.
That thing got shot up straight. Didn't tumble around like a coin.
I don't know, though, with the heat of the nuclear blast and the fact that it would have pushed it so fast through the atmosphere, it would just be like how an asteroid comes into our atmosphere, at supersonic speeds.
I mean,
it doesn't ever reach the ground.
Wouldn't the force of the wind being pushed up against the superheated manhole cool it down the manhole cover?
No, it would do the opposite.
I think the rubbing always just heats it up. Yeah, I think the rubbing only goes up until it gets into the rarefied atmosphere where there's none left, which is a really bizarre thing, right? Because you get really cold temperatures, but something punching through them still manages to get very hot. No?
First, we got to prove that there was a manhole.
Yeah.
What are you talking about my manhole for? You stay out.
I've never seen a manhole.
Well, you ain't looked, boy.
Okay, here's what you do. You get a mirror, you pull your pants down, and then you bend over so that your head's between your legs. And then you look at your manhole.
That's a boy hole.
I don't have a mirror that's that long. I only have
It's your cell phone.
That's not a mirror.
Well, no, but you can use the camera like a mirror.
But that would mean my butthole is optical, not physical.
Careful, man. This guy sounds like he's like a little kid or something.
Oh, yeah.
Got to make sure you're looking at the
Jeremy acts
actual
like he doesn't know
butthole, not
me.
the
I
apparent
talked to him a million times before, so I don't know. Just because it's been a while, you got short-term memory loss there.
Okay, guys, I'll share my screen.
Sure. No, I don't want to see your manhole.
Oh, God, here we go.
Actually, I'm driving a truck. It's got a crane on it.
Driving a truck in your manhole?
The truck through his manhole. All right, I'm stopping.
Now, I'm not saying you guys were born losers, but you weren't given the opportunity to figure these things out concisely. Now, obviously, if the Earth were a globe, evidence would be overwhelming.
How do you establish that claim?
You're right. That's absolutely right. Hey, he's right. He's absolutely right. The evidence would be overwhelming. You would be able to look outside and see rotating stars and things disappearing behind the horizon and be like, shit, there's a lot of evidence. And it would take a really robust.
You could predict travel times and distances and things like that.
Yeah, you could explain the Southern Hemisphere and the Southern Cross being on the flags of all these all these countries in the South.
Kimo,
there would be a lot of evidence. You're right there, buddy.
Kimo, are you really desperate to get wrecked again? Because we can make that happen if you want to get wrecked.
All you have is fallacies. You're gonna wreck them with fallacies. Oh, that's scary.
No, what's facts?
We can talk about fallacies.
You know what it reminds me of? It's like when a kid steals another kid's test from last year that's in the teacher's cabinet, and then calls it his own, and then gets a lower grade than and then acts like he's the one that did it. Y'all, that's what y'all's problem is. Y'all stole all your information from flat earthers, and now you want to act like you own it.
Jeremy,
I can just use, if you want, I can just use flat earthers' information. We can have a conversation. I can just use your own statements to prove you wrong.
What did you do? So show me where there was the evolution in time from flat maps or flat earth maps to round maps. Can you show me where this transition occurred at the exact year that they figured out and they go, damn, it's freaking round, man. We need to remap this whole damn planet now. Can you show me that point? Because all maps up to a certain point were flat. Do we all agree to that at one point?
What are you talking about? Maps are still flat.
Exactly. They were flat Earth maps. All the maps up to 200 years ago were for the people thought it was only like 200 years ago.
No.
Everybody in the world thought the Earth was flat, right?
That's incorrect.
That's just wrong.
What are you talking about? Incorrect. You have no
I'm
proof.
not talking about you. It's wrong.
Okay, well, show me the first school book where they say, "Oh, there's a globe Earth." So let's see that.
If we showed it to you, cranky gentlemen, Could I ask you
Go
a
ahead.
question, cranky gentleman? If we showed that to you, if we showed you the first textbook that showed a reference to a spherical 3D Earth.
Yes, I want to see the first U.S.
Yeah. Hey, cranky gentleman, I haven't finished my question. I just need to finish the question because you don't know what you're answering yet, right? Because I haven't finished. I got to put the question mark at the end.
It's got to be a United States school book.
Okay. If I showed that to you, would you go, right, you guys are right, I'm wrong?
Well, let's see it. We really want to see this.
No. The question comes first, cranky gentleman.
Hey, you've got us all mesmerized. Now hurry up and pull it out and show it to her.
Sure. Okay. If we showed that to you, would you find that compelling?
Man, I'd find that so compelling that does the school books, what does it say? We used to think the earth was flat, and now we know it's round.
Gentlemen. Yeah. Would you find that compelling? Would that change your view? Would you say I am wrong?
If it was really some like hard factual stuff, yeah, it'd probably be pretty good. Let's see it.
If it was some hard factual stuff, we've got to agree on what's hard and factual before I show it to you, because otherwise what might happen is that I would show that to you and you go, well, that doesn't count for reason X. And a reason X, if you'd stated it beforehand, would be valid. But if you state it afterwards, if you go, well, hang on, now I'm going to pick that the cover is the wrong color and the date, well, the Jesuits or some sort of make some crap up, basically.
We know the year that the television was invented. We know the year that baseball was invented. We know the year that a hamburger was invented. We just need to know the year that the ball earth was invented, okay?
I just heard somebody switch on or off their Blue Yeti. I know that sound of the mute button being pressed.
Yeah, that was me.
Okay, how good's my ear, right? That's pretty good, right? It sounds like this. Yeah. Would you find it compelling, cranky gentlemen? Because we can find it, but the problem is what most of us get a bit exhausted doing is you say, show me proof of X, and we do, and then you go, it doesn't count for reason Y.
His name is Dallas Dave. It's not cranky gentleman.
Sorry, cranky Dallas Dave. Would you find that compelling?
We're all waiting in anticipation. You got to hurry.
Just haven't answered the question though. That's the important bit. The question's the most important part.
We all want to know when people started believing it was round. What year was that?
Okay, and if I show it to you, you'll go, therefore the Earth is spherical. Is that what you'll say? Okay.
So we have to have any
like
objections to evidence
1955.
before you show us the evidence. Does that make sense?
Yeah, you sort of present your Whereas if you said to me, I'm going to show you a photo of the horizon being far further than it should be. Do you have any objections to this, or would you find this compelling? I would present to you my objections first, or I would agree that I found it compelling. So my objections might be, well, I would need to know that there weren't any atmospheric effects making the horizon appear further. And if I said that beforehand, you'd go, oh, okay, that's a reasonable thing. Whereas if I just made that up afterwards, you would go, well, that seems a bit shifty, wouldn't you?
Here you go, Dave. Speak now or forever hold your peace, basically.
Yeah. Not forever hold your peace, but otherwise I think we could agree all of us as humans get a bit slippery. The moment we get pinned down to a single point, we go, and then we bring up a different point. We'll come up with a sort of post-hoc rationalization.
Can I ask you a personal question? Do you believe that when they first discovered America that they were thought the Earth was flat when they discovered America? Would you agree to that?
I don't know. I think that's a really strong answer, and I like giving that answer. I don't know.
Well, I mean that would be the point. Because you haven't proven it's a ball up till the time you get to America.
But see, proof is a strong word that I also like to avoid, because proof to me exists in maths. Evidence.
I mean, you've actually went all the way around your ball, right? By that, after you discover America.
I haven't. That's why I say I don't know. Have you?
Well, I don't believe you can go around the world that way, but
right, but you haven't not gone around the world or found the inability to go around the world or come back with evidence of the inability to. So neither of us know, and I think that's a good place where we could agree, right? Neither of us know. What we're doing is offering conjecture.
The school book, I mean, do you agree that people thought it was flat up to this point?
Yeah, people thought it was. Different cultures seem to have thought it was flat. Some seem to have already had some belief in a globe. But yeah, what I would agree with you is many cultures, particularly the more sort of the less informed they are, the less they've spread out across the planet, the less they've managed to master the natural environment.
It would have been like Italy, or Spain, right? They were the greatest shipment of all of Europe, right? They're the ones that basically discovered all of Europe. I mean, all of North and South America. Would we agree to that?
Yeah, I think we'd agree that they certainly did a lot of colonizing and far-reaching.
Do you realize that Spain was the last country to teach flat Earth? They are to start teaching globe Earth mechanics.
Okay, that's fine. I don't understand what that's meant to teach us though, because that could be to me could be anything from a strong religious theocracy.
Exactly. You could actually be worshiping a ball and not even know it. Think about it.
Yeah, and likewise the other way around, huh? Wouldn't that be true of both sides?
Well, it could have been in the beginning, so I'm not sure. That's a good point.
Yeah, so that's why I like that answer. I'm not sure. I think is a really strong answer because it keeps us looking and going, hey, let's doubt the things we're told by other people or we see on YouTube videos.
So basically, we can put the globe Earth kind of starting to go worldwide in what, 1600, 1700?
I'm getting a lot here from this wiki page that I'll put in the chat now, which I find quite useful, which is talking about which different cultures came across the idea of a spherical Earth, it is called the myth of the flat Earth. So, and I don't mean that to sort of be antagonistic, because it seems to answer a lot of the questions you're asking.
I think the problem I have is a lot of people can't admit that they didn't know it was round until they went around it.
No, yeah, I think I would agree with you on that. I think that's a really simple thing to tell kids. Oh, well, Christopher Columbus, the whole reason he sailed and risked his life was to prove the shape of the planet. It's like, I'm pretty sure he did it because he wanted to make, get the bitches and make money and, become famous. I think the idea that, it would be impressive if somebody set off, but I think it's a simple story to tell people. And I think we would agree it doesn't seem to be accurate. I think it'd be hard to say, if you asked me what were my reasons for doing anything, it would be hard for me to give you a full rendition of all of the reasons I made any decision, even what to have for dinner, let alone reach back in history a few hundred years and try and explain some person's motivation for doing X or Y. I think it's just going to be rewritten in history books and impossible to accurately determine. So I think the best answer again remains, I don't know.
Hey, Chemo, I passed the witness to Chemo. Go ahead, Chemo.
Hey, sure you want to do that?
Yeah, go ahead. Or go ahead, Baba Jolie. Hurry up.
Again, I'm not saying that you guys are losers, or
it's a good start.
Well, again, I'm not saying this, but it's just, again, if the Earth were a globe spinning, flying through space, the evidence would be overwhelming. You wouldn't be able to get away from it.
Yeah, I would say it's true. And what I think is right on the side of the flat earthers is it is a positive claim and it would need quite a bit of evidence. I think the flip side, though, to claim flatness is also quite an incredible claim. I don't mean lacking credibility when I say incredible. What I mean is we need to add complexity. The first thing we must establish if it's flat is, does it terminate at a certain point or does it continue forever? If it continues forever, that in some way solves some problems but breaks a whole bunch of others. I.e. the whole gas container, how can you have gas pressure without a container, is destroyed if you add infinity to it, because then you would get simultaneously zero pressure and infinity pressure, and in minus infinity pressure. Just mathematically it won't make sense. So we must say it terminates somewhere. But where the Earth terminates, whether it be the ice wall with a dome that's protected by this giant armada of ships and military, can you see every step we need to make makes it more complex and more complex? So what we're ending up doing is actually balancing two positive claims against one another. The negative claim would be, I don't know, wouldn't it?
Hey, has it been 20
have
minutes
you
yet?
heard of the expression falsification is independent of replacement?
Yes, yeah, but flat Earth is a claim, right? It's not saying not ball Earth. It's not saying not the radius we're told Earth. It's saying flat Earth.
Well,
Isn't it?
I think
Positive
what David
claim.
was saying earlier was he was going through the history of when did this new idea of a globe come about. So I think that's the point. So if the world knew it was flat, and then obviously you're coming along, I would say you're the guy who's come along and said, no, it's not flat. It's a globe because of X, Y, and Z. So it's basically you're saying to the people, no, it's not flat. This is why it's a globe, right?
What I'm saying is I don't know, and then I'm interrogating what flat earthers are telling me to see if it logically holds up. But there's a few problems I've come across so far. Like one of the ones is the horizon is optical, not physical. I think that's a really interesting thing that flat earthers say a lot, because what that kind of throws out is every measurement you've ever made based on the horizon. Because you're saying if it's optical, not physical, we don't know where it really is. All we can do is look at where it appears to be and show that measurement is out. But if it's optical, not physical, what exactly are you measuring?
Nothing. That's the point.
Exactly. That's an interesting point.
So we would say,
and then the other one is
we would say welcome to flat Earth at this moment, because if there's no geometry and things are not disappearing over a physical geometric horizon, and it is apparent as you've just stated, then what are we doing with the R value, making calculations of how much a building should or shouldn't be seen, a mountain should or shouldn't be seen? I mean, that's just nonsense, right?
So what you're saying is that number's wrong. If what we're given
but
for
what I'm saying is that you're saying, well, you can't use the horizon. I agree with you 100%. You're like, oh, well, you can't use the horizon. It's just optical. It's not even physical. Yeah. But I think the idea was when mountains are obstructed, boats, buildings, such like, the globe boys would get the calculator out and say, hey, do you know what? This is how much you should see or you shouldn't see behind, of the obstruction. So, so in one breath you're saying, well, it's not physical. Don't use calculations. In the next breath you've got the globe and making calculations. So you can see where I'm coming from, right?
No, I'm not. You're putting words in my mouth there. I'm saying I don't know. That's
I'm saying that you're agreeing that it moves the horizon, yeah?
Yeah. Well, it appears to me. I don't think the actual physical land is rising or falling
how
down.
can you make measurements and calculate it, right?
Yeah.
And I'm like, yeah, I agree with that 100%, because that's what we're told. We're told that when things are obstructed beyond that horizon, the globe boys get the calculator out and start using geometry and start figuring out how much shouldn't or shouldn't be seen. That's crazy, right?
Yeah, I think you just said something, and I just want to be clear that we're on the same page here. You just said it cannot be measured. The horizon cannot be measured. Is that correct?
No, that's what you said. You said that.
Right. Yeah, that is what I said.
That is what you said. So you said to me, if I were to talk about the horizon, and I was going to say to the flat earther, how is he measuring the horizon, like, if it's moving all over the place, right? That's what you said, yeah? And I was like, I agree. That's what we would say. How are we going to apply geometry to something that's moving all over the place?
This is where I'm trying to get to where we agree. It sounds like what you're saying is it's impossible to measure the horizon, and
I didn't say that. You said that, and I agreed with you.
Okay. So what are you measuring what is the black swan doing? That black swan photo we've all seen, because we've been talking about flat Earth for a while now. What is the black swan actually showing us then?
So it's showing us
to disprove the globe Earth.
No. Let's go back to what you said. What I agree with. You said, how can we measure the black swan or any horizon when it's constantly moving? Yeah. And I said, yeah, that's exactly what you said. That now
I want to just clarify what I was saying. It is, if one of my assertions is the horizon is optical, not physical, it is where something appears but may not exactly be in reality. Then I think that is at odds with then saying I made measurements based on its appearance. Because
exactly. Again, I agree with you. Yeah, this is my point. Sure. So any horizon that we find with an obstruction, it would be ludicrous for a ball earther to start getting out the calculator and performing geometry of how much should or shouldn't be seen, right? That'd be just nonsense. That'd be like, what on earth is he doing, right?
Can I just take a poll here?
No.
Can I take a poll of people in the room?
No, hold on. No. Don't deviate. What's your name?
No,
I've never spoke to you. What's your name? What is it? Riding
on eggshells.
Right. So listen, you said the horizon because you thought you were attacking me with the flat Earth and the horizon. You were like, well, you can't measure it because it keeps on fluctuating.
I try not.
So I was like, you didn't say fluctuate. You said it moves. you can't measure it. And I'm like, yeah, we know
The
this.
apparent location moves.
And I was like, yeah, I
Yep.
agree. The apparent one is constantly moving, so how can you possibly measure it? So I said to you, the globe boys, when things are obstructed behind that apparent horizon, they whip out the calculator and start making calculations of how much should or shouldn't be seen. So as we agree, as we both agree, this would be nonsense. I think
we're on the same page here.
No,
wait.
not on the same page because
come on now.
Nemo is trying to interpret that the constant moving measurements as being one fixed measurement invalidates the constant moving measurements.
Look, let's not derail.
More important here is what Kay is saying is that when the globe boys see something, they whip out their calculators. Can I just do a poll of the people in the room who believe in the ball or spherical or bladed spheroid Earth?
Oh, they're all.
How many
this
of
is
you
the globe room.
believe the Earth? Hold up, Kay. Let me ask a question. How many of the people who are globers here believe the Earth is a ball because they made measurements of the horizon? Just by a show of like spams in the chat or something.
No.
I said no.
None of them.
None of them. No.
None. So that's kind of at odds with what you're saying, isn't it, Kay?
No, not at all. I've just explained to you. Do you not listen to what I've just said?
Yeah, hang on, Kimo. Let me just
hold on,
That doesn't conform to my
one last point.
my
Jim.
script.
Did you not listen to what I said?
None of us claim the Earth is a ball based on observations to the horizon, but you are trying to say.
So let's talk about that. Let's talk about that.
Yeah.
So when listen to what I'm saying. When things are obstructed beyond the horizon, do globe earthers make calculations on how much you should or shouldn't see?
Oh, I see. Do ships disappear hull first?
No, listen to what I'm saying. Listen to what I'm saying. Listen to what I'm saying. If a mountain is obstructed, do globe earthers calculate how much should or shouldn't be seen based on atmosphere, curvature, all that kind of stuff? Do they get the calculator out and calculate?
Sure. I had. Yeah. Let me.
You haven't thought of that yet? Over to you, Jim.
Yes, of course.
I realised I'd misrepresented or misstated your opinion. It sounded to me like what you were saying is globers believe their claim because of measurements of the horizon.
No, I'm saying that the horizon. I'm saying that the horizon is used to calculate how much should or shouldn't be seen. But we both agree that doing that would be a waste of time. Because as you told me, as you initiated this conversation, you said the horizon is constantly moving. So you said, how can you make measurements to the horizon?
Hang on.
No idea who's saying
that again and again. He's trying to conflate as though there is one specific horizon that is used in all these calculations, which is not.
There is.
Chemo, this guy never heard about
actually considerations.
No.
Which measurement to the horizon is being used.
I disagree with that completely. There's an ideal horizon due to the physical nature of the Earth, right? And then there's one that's been adjusted by the atmospheric conditions. That's it. That's it.
Chemo, tell them about the dip angle with Alberoni.
Ideal horizon.
Yes, there is
one that's been distorted by Earth state.
If I may be allowed to get in now, because everyone's jumping all over the place, let's just get some order here.
Correct.
Right.
There is
riding. Hang on a second. Riding. Hang on.
However,
can I get some order here?
He's trying to conflate that as being invalidating of all the individual measurements that arrive for you to build the convergent one.
I understand what's going on.
Can I just get some order in here now? Now look, riding on eggshells. You've been into the 24/7.
Yeah, we've chatted a lot.
Yeah,
before.
Good day. You say you've been there,
mate?
Right. So you know where we're coming from with the horizon and the geometric horizon. Yeah, following the specifications. Hang on, following the specifications that we are given from the astronomers, the geocentrists, the who else is it? The theoretical physicists. Cosmologists, they give us the size of NASA. They give us the size 24,901 miles with a radius of 3,959 miles. Okay. Now, based with those numbers, and you're at the ocean, right, at 1 foot, let's just say for simplicity's sake, 1 foot off the ocean, your geometric horizon, when you square root the observer height, should only be 1.22 miles. Yeah, that's how far your horizon should be according to the specifications. And if you're seeing anything beyond that, that's clearly telling you that the Earth is not of the size we are told.
If
And
you're
we're not
seeing any,
colours.
okay.
Hang
Let
on.
me pause on that point.
That is completely and utterly wrong.
Guys, can
wrong.
I respond to
It's
Jin?
wrong.
He asked me the question, and I don't think shouting wrong at people is going to get us anywhere. So what I think you're saying, Jin, is when we're told about the ball Earth, we expect to find a geometric horizon in a certain place. And
Correct.
when we do not find it there through observation, we therefore know that the R value is wrong. Is that
Yeah,
close
that's
to what
correct.
you're
Yeah,
saying?
yeah. And observation
Okay,
through, hang on a second,
so-
please. Hold on a second. Observation through measurements. Yeah. So this is a concise and deliberate action. Yeah. We're not just playing around here. Right.
So I just have a couple more questions for you. Yeah, can I have a few more questions for you on that? One is, what are you measuring? And the second question is, how are you measuring?
Well, what are we measuring? We're measuring the actual distance to objects according to the size of the Earth that we've been given. Okay. So if your geometric horizon is supposed to be at hang on a second, please, at 1.22 miles, and then we've got, like, the famous Black Swan, we have an oil rig at 6 miles. So already there's a discrepancy. Then we have one at 10 miles, still there's a discrepancy. And then the horizon is way beyond that. And in some images, we can see, hang on, please, we can actually see islands further on. So we are looking at a leveled, you can imagine whatever you like. Logic and common sense from your eyesight says that's level. There's no curvature there.
Yeah,
Right.
I'd agree. What I'd agree with you on, it sounds like what you're saying is, I'm doing the measurement to an object of a known distance, and then I'm making an observation of the horizon beyond that, and that is how I'm taking that measurement. But then in the next breath, you're saying the horizon is optical, not physical. So what it sounds like you're saying is, I'm measuring the apparent horizon, or the horizon is something that is apparent, and I'm measuring the horizon. But I'm accepting that is optical, not physical. So you're measuring the appearance of things or the actual location of things.
You see, now what you actually, this is what we're measuring. We're trying to measure. We're trying to measure the geometric horizon, the actual, the actual horizon that we're given. But
we agree we cannot, because we don't know how to look for it. Right? We don't know where it is because it's optical, not physical.
Hang on a second. Hang on a second. That's we have a bad habit of doing that. That's terrible. Stop that as a professional reporter that you say you are. Don't be doing that kind of nonsense. Just listen clearly, and then I will tell you. Hang on. Don't interrupt me now. There's supposed to be a geometric horizon at a certain distance. It's not there, okay? We're seeing other objects beyond that. And then the horizon beyond the two objects, the oil rigs. Now, we're not measuring to that horizon. We're not measuring to that. We're seeing that the horizon is beyond the object. So it's gone beyond the specified geometric horizon. It's gone beyond that, yeah?
Do you understand the
question
question I'm asking?
Geometric horizon is the exact one that you're going to measure at any given time. That's why we take measurements of fucking dry, cold days and stuff like that. You know this shit. You've been given the examples.
This guy just said we don't measure to the geometric horizon.
I'm saying that the ideal would be the geometric horizon, right? Like that, there's an actual horizon, right, which would be the geometric horizon, but because light is being bent a little due to atmospheric conditions, it looks to us like it might be the horizon is over here, or up here, or there. But it's always in a particular location, and it's always based off of the geometric calculation.
No, that's crap. That's crap. It's absolutely ridiculous.
Why is it crap?
Can I finish?
Tell me why.
Because the horizon should only be 1 mile, but we're seeing 6 miles, objects, 6, 10, and then the horizon is beyond that. How far beyond?
1.2 if everything's 0 and 0, right? Like, but you're not. You're 6 feet off the ground or whatever.
No, we're not. We're a foot off the ground.
And the object is however amount off the fucking ocean.
12 inches it is. 12 inches. That's what it was. 12 inches.
And a boat is how many feet off the ground?
1 feet. 12 inches. Bloody hell. 12 inches, 1 foot. That's what it was. 1 foot, that was.
What
if you're at 8
somewhere
feet,
useful?
If you're at 8 feet,
what if there's...
Let me just finish this. If you're at 8 feet, then your geometric horizon should be 3.46 miles, but it's still short. It still falls short, doesn't it? Because
So
we're still
what?
seeing beyond that. Okay, so there you go.
So
Carry on,
what?
please.
So what?
So
What
what?
is your point?
The globe doesn't exist. So the
Why?
Earth is not a globe because we
Okay.
don't measure the curvature.
All right. Well, we can do the same thing with cars on the desert. Like if I went to Death Valley, right? And I drove a car miles away, right? You would see it slowly start disappearing and it disappear, and you could take measurements of that, but it'd be very weird measurements because there's a hell of a lot of fucking distortion going on optically.
There is no distortion going optically with the oil rigs and that where we're looking for.
Are you kidding me?
Bendy oil rigs.
3 mile.
I think bendy oil rigs that have a crane that looks like a duck.
Black Swan disproves you. I mean, your own fucking evidence disproves you.
No, it does not, because, like I mentioned, we're looking for a 1 mile geometric horizon, or if you're at 8 feet, a 3.46 mile geometric horizon. But it's not there because we've got objects. We are able to see objects beyond that. 6, 10, and islands at 30 miles away.
How can you not notice that there's different atmospheric conditions in those fucking two examples? How can you not notice that? Are you retarded?
No, you're retarded because you don't understand what I said,
I do understand. It's nonsensical.
You don't understand.
This went
You're
down.
clearly sick in the head.
That's because I'm aggravated these days. I'm sorry. I'll shut up.
Right? Yeah, I think you should, actually.
I think you should go and
pack yourself up and go to bed and go to sleep. Sleep off all that alcohol, I think.
There ain't no fucking alcohol in my system, asshole.
Yeah, I'm sure. You don't sound coherent at all. Simple enough, because you seem to be mixing. You're trying to say this.
I don't sound coherent.
You're coming out incoherent there with your two horizons.
Jen.
You're mentioning 2 horizons. I didn't mention 2 horizons.
There isn't 2 horizons. There's 1 fucking horizon.
You're attempting to make a claim about geometry with optics, and then rejecting everything that goes into optics, such as refractive effects, when making that argument. That's nonsense.
I'm not making an argument, and I'm not saying there is refracting, but there isn't. In the images that I provide you, that I provided you, there is no refraction because you can clearly see the objects. They're not being refracted up from anywhere because we're above. We're at 8
Okay, that's an interesting thing to explore,
Jim. Looking down at those oil rigs, and we can see them clearly. So there is no refraction, and we can clearly see the horizon. Now, if you go there,
could I ask you a question
you may
about
not be able to see the horizon clearly because of atmospheric conditions. Yeah, okay, that is true. That sometimes atmospheric conditions do change what you can see, but
Jen, please, Jen, sorry, Jen, hello, can you hear me? Can you hear me?
You've got to be interrupted when you rant.
Yeah, stop. But Jen, just they've got to be able to respond, and give the globe perspective, if you will.
What?
Please.
Yeah, okay,
Yeah.
I see what you mean, Chemo.
Thank
Okay, carry on
Thank
then,
you.
guys. Please carry on.
So the statement seems to be, we do agree that the horizon moves, but then you said there is no evidence of refraction in that picture, or we know that picture of the black swan with the horizon beyond it is not an issue, is not a result of refraction. Could you show your working for that? How you controlled for or excluded that as a possibility?
Just by looking at the image, and you can actually see the image I presented you the other day here in this server and on the 24-hour Discord. Yeah, the image is clear enough that you can see that there's no refraction because you can actually see the objects. They're not being refracted up anywhere, and you can clearly see the horizon yonder.
So how did you control for that? Because I see one thing and you see a different. So how can we pass the difference?
Hang on, because you're talking over me. Quantum Razor went ballistic when people started talking about refraction, and then he asked you, which refraction are you talking about? Because there's 5, and then it all went silent. But anyway, carry on, please. Do carry on.
No, so what I'm saying is, sure. So what I'm saying is, when I look at that picture, I see bendy cranes and wibbliness. So I think I do.
Not in my picture.
Hold up, Jen. I thought you didn't like when people interrupted you, buddy.
Okay, yeah. Well, you're talking about the image you saw, not the one I presented.
So when I see the black swan photo that everybody presents that has bub by ball at the top,
Yeah, I've got barbed board on top of mine.
Sure. So it has a wibbly crane, and when I see it, I think, oh, that looks like refraction. And when you see it, you say, I don't think there's refraction. So how could an impartial observer weigh that up? Because when you say, oh, just look at it, we are just looking at it. So what measure would you use or heuristic might you use to discount one over the other?
You see, for me, that image you're looking at, I would say it's poor quality anyway. That's the first thing I will say, which is why I never ever offer up that as an image to debate on. The one I offer up is where the observer height is at 8 feet. It's kind of like a sun-setting sky. It's a different image entirely, different time of day. Okay, that one is not very good. But even though I will comment on that particular one that you've seen, the fact, because the crane is bending, I can still see the oil rigs and the little boat and the horizon yonder. So there's no refraction going on there. Whatever you're talking about is just atmospheric condition that's interfering with the resolution for the camera to pick up detail. It's not bloody refraction you're going on with.
Yes, but I'm asking how. What measure do you use to discount her refraction? Well, it sounds like what you're saying is I look at it and I'm pretty sure there's no refraction.
I'm using years of experience of taking pictures outdoors and know full well that a camera can pick up things when it's totally clear and will have difficulty pick up certain fine details like that crane. Okay.
So can I give you an example of the kind of? Sorry, carry on.
The body of the crane was picked up well enough and the horizon yonder. So basically, to claim refraction is a joke and a liberty. Should be banged up for that. But carry on.
So let me give you an example of what I'm describing in a different context. When
carry on.
When I fix my motorbike, sometimes you'll get a problem where it won't start, and you've got to be like, right, there could be 5 different explanations for this phenomena of it just not ticking over. The battery could be flat, battery could be powered, but there's a break in the electrical somewhere. Somebody could have tried to steal my bike and cut a wire somewhere. It could be not getting fuel. And then what I will do is I'll go through a procedure of trying to figure out which is which, each of which will involve applying a kind of heuristic or rule or test that says this is going to exclude or include one thing or the other. What it sounds like you're saying to me about this thing is, I look at the bike and I know bikes for ages, so I've decided that it's a battery problem, therefore it's a battery problem. Where I would say,
no, that's
how
ridiculous.
can we do it in an objective way where even a brand new person could come in and you say, well, take out the battery, tap it, get a spanner, hold it on the positive terminal, and then pop it on the negative terminal. If it sparks, you probably got stuff in your battery, so you can move on to a different problem. So that's an objective,
right. So why do we act like we know everything about this bike? Why are all pictures in the daytime? Where are the night vision pictures? Where's the night vision?
That's not a useful question. That's not a useful question. That's not what we're discussing.
I already have a question.
So do you see Jin, do you see the question I'm asking you, which is like objectively we can determine one from the other?
You are asking, okay, but refraction is due to atmospheric pressures which are out of the cameraman's control. It's natural, isn't it?
Yeah.
I've got an instrument. Hang on a second, please. I have an instrument that will do its best to take its best picture regardless of what's going on. Yeah. So if you've got bendy camera, but yet you see the body of the crane 1, 2, and the horizon yonder, you can't claim refraction. You can't.
I'm not trying to claim refraction. I'm trying to exclude refraction as a possibility.
How can I control the air conditions? The only way I can control it is to take a picture on a good day where there's no atmosphere.
That's a great idea. It's a great idea. Yeah, take multiple photos on different days.
Let me finish. Please let me finish. That is why I say that the images that you have seen are of poor quality. I would never offer that up as, have a look at this picture. I would never do that. I would wait till the conditions are perfect so that you can see everything clearly. And that's my only best way to reduce what you would call refraction, even though in the image you're looking at, there is no refraction anyway.
Hey, Jim, can I ask you night vision black swan?
I have a question on
just on. Yeah, real quick. Jen, for all the people listening right now that don't understand that you know what refraction is, can you explain it to them real quickly so that they'll get it too? Can you tell us what refraction is?
Refraction is just the bending of light is affecting the image you look. It's supposed to bend the image down or the image up. That's my understanding of refraction.
And tell them how you know if the light is bending or not.
Well, I couldn't, could I? What I'm looking at is what I'm looking at. What you call refraction, you're saying to us that the image is being lifted up from beyond the curve.
Did you just say I couldn't? Did you just say I couldn't tell if there's refraction or not?
Yeah.
It sounds like in the other bit you're
What
saying
I
the
mean
opposite.
It's that easy, dude. It's that easy.
What I'm trying to say is this. What I'm trying to say is this, yeah. You people are saying that the image is being loomed up or lifted up from behind a curve. I'm
And you're saying I have no way to say that's not the case.
Incorrect. Because
Jen, you said quote, and there isn't anywhere. You said there, and there's not.
There's no refraction. Yeah, there's none. Because I can see these objects and the horizon clearly. There's nothing refracting. It's not, no light is bending.
Some of the things you're saying are at odds with one another because you just said there's no way to tell if there's refraction. Now you're saying I know for a fact that there's no refraction. So you're making a positive claim to a negative, and then the next breath saying it's impossible to determine refraction.
I misspoke earlier. What I'm trying to say is this: in the images that we look at, there's no refraction there because
how do we tell that?
You keep interrupting, and I'll carry on talking if you do that. Basically, we can see that your first stumbling block, which you're totally ignoring, is that your geometric horizon, according to the globe ball, at an observation height of 1 feet, should be 1.22 miles. So the very first, your stumbling block is we have one oil.
Please, but with the
you're
water
ignoring
moving,
refraction.
margin of
You're
error.
not listening now. You're not listening at all. You're all
No,
jumping
because
the
you're
gun.
just repeating nonsense, and you're
I have
ignoring.
to repeat.
Hang on.
I
You're
have to
repeating.
repeat it. I have to repeat it because you're missing that point. You're ignoring it.
We're not missing that point. You are ignoring. You are ignoring refraction. Listen. You are ignoring refraction, and you. All you're doing is simply asserting that there is none, but you aren't saying how you are able to determine that there is none.
Well, I'm telling you this.
Listen.
Listen.
Hold on. All you're offering us is, well, there doesn't look to be any. And another thing you've said a couple of times is, I can see these objects, as if if there is refraction, you wouldn't be able to see the objects.
Well, yeah, of course.
Well, no, not of course. That's not true in any way.
Curious question.
Well, you guys are saying the
refraction doesn't make things invisible.
No, but it bends them up, though, from a curve, is what you are saying.
Yeah, but you're saying because I can see them, that tells me there's no refraction.
Absolutely.
How?
Because
so that would imply for there to be refraction, you would have to not be able to see them.
Well, according to you guys, yeah.
No. According to you, that's what you've just said.
According to you,
no, that's not true.
According to you, lot, you're saying that.
No, not according to us. You've completely misunderstood. You have completely misunderstood. Refraction does not make things invisible.
No, I didn't say they did make them invisible. What I'm saying that your
refraction does make things invisible.
What is your claim with the? That's why we asked you what refraction.
You are a nightmare. You are a nightmare.
There are 5 refractions, gentlemen.
Oh, no, everybody's engaging here.
No, there are 5 refractions.
We should stop.
Nightmare. Just shut your trap for a little bit.
You guys are asking me the question.
Yeah, be respectful.
You guys are asking me the question.
I don't think shouting at Jin and then complaining that he's shouting back is fair play.
Thank you. And you guys actually.
I don't think he's stopped shouting since he got here, dude. So I don't think we have to worry too much about being polite and respectful.
No, I'm just saying it's going to be a make for a more fruitful
Jin, dude. It's never ever going to be reflected. I promise you. Doesn't matter how reasonable you are, he will always be mental.
I'm reasonable, mate. I'm reasonable.
Like it's a break in a car.
Look, when you guys claim refraction, you should specify which refraction you are talking about. That's the thing. That's where we get confused. Which refraction are you guys talking about, please? Because you know there are 5 of them right
It's
now.
called, no, that's not the types of refraction. There's one type, downward refraction. That's what you're talking about. The effects are looming, stooping, sinking, towering. Those are effects, Jin. Those are not refractions.
They are refraction according to what I've learned. They are different types of refraction.
God dang, you're so annoying.
That's what I've learned. That's what I've learned. They're all different types of refraction.
Just accept it. Just accept it.
No, I'm not gonna accept
It is what it is.
I know.
It is what it is.
I know. Downward refraction is what causes looming. And if we have downward refraction, which is what causes this refraction, causes looming, then things will be higher than they would normally be geometrically. And that's what we see. It's that simple, Jin.
Your problem is this, yeah? You're saying that the oil rigs are being loomed up for 6-10 miles, and then the horizon, which is beyond that, all that's being loomed up. That's what you're saying. That's what you are saying. Am I wrong?
Jin, you're cutting out a bit at the moment, buddy.
I said,
we didn't hear the end of your question.
I'll ask that question again. You guys are saying that the 2 oil rigs and the horizon, which beyond that, is all being loomed up. That's what you're saying, yes?
I'd say it's possible. I don't know is my answer, but I would say it's possible.
BS. Absolute BS. Because we can go to other places around this earth and do long distance observations, and you can't be looming that up. Everywhere is looming everywhere. Is there no one day where it's clear, where it's not looming, and we can still see? Yeah, that's why I put up my image. It's a better image. You can't be claiming refraction at all. You can't. It's just too clear. And the clearer the day, the better.
Let's see your image. Where is your image, Jin? I haven't seen it yet.
Yeah, that's actually I think that's a fair thing. If you've got a better image, we should be, rather than straw manning you against an image you agree is low quality.
Good thing I haven't got a match. I'll be burnt up now. The amount of straw you guys are throwing at me.
That was good.
Curious,
I like that.
Jin, under what you have
That we're in for a
learned,
laugh now.
refraction,
There's my clear image, Jim. That's one I prepared earlier.
That's me being reasonable.
I think you are, generally speaking, reasonable. I think you get excitable. So do we all.
Yes, especially when the truth is being twisted like there's no tomorrow. Bloody hell. And tomorrow will come, I hope.
No, that's not true. People just disagree with you, and then you scream.
Yeah, but then you offer up something that's just totally absurd. Sorry, I'm looking for the image while we're talking. And you offer
It's
up
not
something
absurd.
that just blows my mind. And here we are. I got the image, and I'm clicking on it. And I say,
Well, Jim, the rest of the world thinks it's perfectly sane. You're the one who thinks it's weird.
yeah, just
but
because
that's
the
the case
rest
for
of the
everybody
world
on all
makes it
sides of
fine.
every issue.
Hey, can I just drop a shout out real quick to Jin?
Just
Jin, right
the
on
truth
that.
is the
Good chatting here,
truth.
bro.
And a lie is a
That's
lie
all
if
you
everyone
do, bro.
believes it. There you go.
Good job, Jin.
Thank you. It's coming now. Sorry, a bit slow on the Wi-Fi there now. I'm trying to send it. I've whipped the mouses. There you go, the Mises. There you go. That's the image I'm talking about.
Right, so that's certainly. I'm seeing less wibbliness in the cranes. I still
Thank
said
you.
bend,
Right.
bend in the in
And
one of the back ones, but it's a lot.
the horizon has been clearly highlighted for you, so there's no mistaking where that is. Yeah.
Could I see the original? Could I see original of that image as well without that drawn on horizon, please?
Well,
I think you're right about where it is. I just love to see it.
What I can only, my best thing the best thing I can give you is a video of that location. I can give that usually I send it with the video, so I can do that for you now. If you give me a few minutes, I will give you a minute.
The globe model doesn't say that the horizon can't be behind objects that are distant on the horizon. It just doesn't say that.
Look, the globe model doesn't exist, so it doesn't say anything, actually.
But let's not
It
jump
says
off
it's
negating the
it
entire
says it's
discussion we're having.
impossible. The globe says, I'm impossible to live on. They're lying about the earth. That's what the globe says, actually. Talk about saying anything.
No, it doesn't say that. It doesn't
It does
say
say
that.
that.
No, that's what
You
you
can't live on
think.
me. It's impossible.
Right after Jim.
That's what you say. You say that.
Blasphemy at the highest degree. Stop them from lying about me. That's what
But
the
that's
globe
what
is saying.
you say. That's not what the globe model says.
That is what the globe is saying to me, mate. They're lying about me. I cannot exist in space in the vacuum. It's a ridiculous thing to think of. Stop them, please. Stop them.
Where is Jin hearing these globe voices from? That's what I wonder.
Jen, can I just say something to you? I've told you this before. Why do you think your little green line of the supposed horizon in the background with your pink arrows, why do you think the thickness of what is a fog bank actually is thinner on the right and thicker on the left? Did you notice that at all?
I could barely hear you. You're talking about the thickness of the arrows and the horizon left and right. Yeah.
So what you think is a horizon is actually fog behind it. Now, yes, sure, you shouldn't be able to. By the way, that's not observer feet of 8 feet. By the way, that's not an observer height of 8 feet. That's when it's 35 feet up. It doesn't really matter.
Watch the video from the very beginning, and you'll see that he's actually in a restaurant or somewhere, a cafe or something.
Yeah, and they're not. It's not on the water. It's
not on the water. No, it's not on.
It's about
the water.
35 feet high.
No, it's not 35 feet high. It's 8 feet.
Yes, no,
it's not 8 feet.
Not. I used to live down there, Jen. Come on. Who do you think?
I'm not going to take you. I don't care.
There's no restaurant right there. There's no restaurant.
We're gonna have to go we have to go with the information given.
No,
and
you
the
got
video is there.
Your brain.
Look.
You don't have a brain.
Listen. Anyway, I'm going to shut up and let
Watch
him
the
talk.
video. Watch the video. You can see it yourself.
Watch the video. It's 8 feet height.
It doesn't matter, and I'll tell you why. Look at how far. Hold on. Look at how much further below the first platform the second platform is. And then when you look at the black swan picture, look at the level, as I just said, of the two platforms with respect to one another. Look at that picture, Jen. How do you think they get?
I've offered you the best picture.
There's
you've ever seen of this.
example of where that picture was taken.
Great, your picture.
Your picture's 35 feet. That's what this is, 35 feet. Forget it. You know.
Of course I do. That's why I bring it up, because you guys have always been complaining about wobbly cranes and all that. Now you can clearly see these objects.
You can't clearly see anything. That's
of course you
bollocks.
can.
No, you can't.
Admittedly, it's not
foggy and a bit hazy.
Yeah, it's not.
And,
I mean, again,
right.
I would
clearly
like to
see
take a better
anything.
picture myself. But of all the images you've seen to date, this is the best one.